Welcome back, and we're going to start now with our look at analgesics. This is going to be a combination of our D2 and D3 parts of our option. We tend to do it this way so that we can look at analgesics or pain medications as a whole. D2 looks at aspirin and penicillin because they're both obtained from natural products, so it kind of flows on from that D1 idea of where do we get our medications from. But we will look at aspirin now as part of analgesics because it's part of pain relief, and then we will look at the second part of D2 penicillin when we look at antivirals and antibacterial medications because it fits really well in with that. So there are a couple of other videos linked on this slide, and I do recommend that you watch them. In particular, this short TED video, which is about 4 minutes long, which goes in about how pain actually works, which gives you a bit of an idea then on how painkillers will work. Just remember this video in particular refers to COX-1 and COX-2 mechanisms, and we don't need to know that in specific, but it gives you a good bit of background on what we're going to talk about in this video. Okay, so we're going to break this down first, and we'll look at aspirin in particular in terms of the understandings that we need to know. So you can see here that it's listed as a mild analgesic, and we need to know the function of how mild analgesics work by intercepting the pain stimulus, that it is prepared from salicylic acid, and we will actually make aspirin in class so we can see how that preparation is done. That it's also used as an anticoagulant, that one of the side effects of aspirin now has become one of its main therapeutic uses, that we need to describe this term mild analgesics and explain the synthesis, and also this idea of synergistic effects. This first video, however, we're going to concentrate on how the pain mechanism works and what we mean when we're talking about mild or strong analgesics. And then in the follow-up video, we'll actually look at aspirin in detail. So we've all experienced pain, unfortunately. I'm quite sure we have, whether it just be stubbing our toe or kicking something, touching something hot, or getting a sunburn. And essentially, pain is a very important part of our body's defense system. It tells us to pay attention, that something is occurring that shouldn't be, and that perhaps our body and that is under threat. So it's essentially our body's way of saying, something is happening that's causing damage, or I am under threat of damage occurring. So we pay attention, we cease that action or behavior that is resulting in pain, or at least we hope we do. An analgesic, however, is a compound that reduces or relieves or even prevents pain. So analgesic is the term given to the group of compounds that act to relieve or reduce pain. We're not talking anesthetics, so an analgesic is not an anesthetic, so we're not talking local anesthetic or anything cause a numbing sensation. This is simply, I have a headache, I take a Panadol, or I broke my leg and have sustained pain, so the doctor has prescribed me pain medication to be able to better cope with these pain sensations. They don't ever cure the disease. They may reduce some inflammation, but generally they're just there to block the pain signals or to stop you from feeling that pain to cause greater comfort while you heal. Okay, we classify them as mild or strong, and this classification is all about where the compounds work in the pain pathway, whether it's at the site of the pain or later on in our central nervous system or in another part. So mode of action is basically what we're talking about there, how they work and where they work, and we need to know this for mild versus strong analgesics. Both mild and strong stop pain signals, okay? The difference is how they do about those. So mild analgesics work at the source of the pain. If you hit your hand with a hammer, then mild analgesics will work at the nerve endings in the hand or around there. Whereas strong analgesics, they all work up in the brain. Okay, so the pain signals are still going from the area of the pain in the pain receptors, and they're being passed along up to your brain and central nervous system, and that is where strong analgesics work. So they're not working at the site of the pain. The site of the pain is still there and the pain signals are still being sent. They're working up in the brain and changing the way that those signals are received. Okay, so a couple of specific terminology points that we need to know. How much pain we feel, okay, is determined by nerve receptors called nociceptors. These are pain receptors at the site of the pain. Okay, they are susceptible to the release of compounds known as prostaglandins. Okay, these prostaglandins release chemicals and respond to chemicals for the transition of pain impulses from the source of the pain back to the brain, where the brain can interpret those messages. Okay, so they also monitor or control fever and inflammation, which are two things that often come along with pain as well, because they're part of our body's defense mechanism. So prostaglandins, which are the compounds, are released from cells that have been damaged in some way, and the release of these, okay, sets about the inflammatory response, sets off our nociceptors. So these nociceptors and prostaglandins are tightly linked in the way that they work. Mild analgesics control pain by intercepting it in this system here. So they're working on the nociceptor prostaglandin mechanism. Okay, so and these cyclooxygenase, we don't need to know those specific ones like the COX-1 and COX-2 in detail for this part of the option. Strong analgesics, however, which are our opiate-based painkillers such as morphine and codeine, which we'll look at in more detail, work by blocking the receptors in the brain. So this nociceptor prostaglandin mechanism isn't interfered with. It still goes along, but the pain signals now are blocked in the brain and the central nervous system. So it basically closes the door to the signals and says, no, not listening, not receiving any pain signals from you, and shuts the brain off from reacting to that pain. Whereas the nociceptors and prostaglandins, when we use mild analgesics, they stop the pain signal from getting to the brain in the first place. So essentially, pain occurs, pain receptor sends a message to the brain. Okay, so the pain receptors are our nociceptors, so they say, ow, something's happening, pay attention. Okay, the signal travels up the peripheral nerve to your spinal cord. Okay, then neurotransmitters and other things associated with nerve transmission, okay, pass the signals up into the brain. So it's this process that we block with mild analgesics, and then it's this process that we're blocking with strong. Okay, and that's the main thing you need to remember, that the mode of action for mild analgesics is your nociceptor pain receptor blockage, and then for strong analgesics we have to get our compounds up into the brain for that to work, and that's the main difference between them. And then we'll look at some examples and look at these mechanisms in detail in the next two videos.